In this video, we're going to be looking at how you can restrict the domain of composite functions so that they exist. So previously we were looking at composite functions, explaining what they are, and then we had a look at if they exist or not. So if the range of gx is in the subset of the domain of fx for f of gx, or if it's the other way around, then the range of fx being a subset of the domain of gx. But for this one, we had to look at if the range of gx was a subset of the domain of fx. We said that if that didn't exist, then if that wasn't the case, then the composite function didn't exist. But now we're going to look at how we can restrict the domain of the new function so that the composite function does exist. So the reason for this, the range of gx has to be the subset of the domain of fx, is we've replaced x with g of x. So before we had a domain of fx, but now x has been replaced by g of x. So then the results also have to be part of the domain. So the range has to be part of the domain, or else you're going to get values such as f negative 2, which may not exist, for example, if fx was equal to the square root of x. So firstly, we begin with two functions. So y is equal to negative x plus 2, and fx is equal to the square root of x. So if we look at fx as gx as the composite function, or like fog, then this is equal in equation wise to the square root of negative x plus 2. So here is gx. The problem with this though is we could let x equal 2, well not 2, let's say 4. If this was the case, we'd get the square root of negative 4 plus 2, which is negative 2, so it's not defined. So that means we need to restrict gx. So we need to restrict gx so that the range of gx is a subset of the domain of fx. So the range of gx has to be a subset of the domain of fx. Now we can't change the domain of fx. So for this case, that is x is greater than 0. What we can do is we can change the domain of gx to mean that the range of gx is changed. So now we want the range of gx to be x is greater than or equal to 0 as well. But instead of x, it's going to be gx, because we're talking about range. So we want the gx has to be greater than or equal to 0. We want to know for what x values this occurs. So we want negative x plus 2 has to be greater or equal to 0. Now we can plus 2 to the x to the other side, and we get 2 has to be greater or equal to x. So x has to be greater or equal to 2. Now, if we restrict the domain, so this is what I mean by restricting the domain. If we restrict the domain of x has to be greater or equal to 2, then that means g of x, the range, has also been restricted. So by restricting the domain, we have restricted the domain. So now the domain is gx has to be greater or equal to 0. As now the range has been restricted, the range of gx has to be a subset of the domain of fx. So now this equation exists. So what we can write is we can write that the final equation is equal to the square root of 2 minus x, so it's gx, with the restriction that x has to be less than or equal to 2. And we can just see that if you didn't know that this was a composite function, you could see this equation straight off, and you could see that this is the case. So with looking at this range domain method, it is useful, but a good way to check is looking at the final equation and also seeing what the domain restriction should be once you've subbed in gx and fx and you're only looking at the equation in terms of x. So the process you can look for is that for f of gx, so if it's the other way around, then just change around when gx for fx. So this is for f or for fog. So that means we restrict the domain, so the domain of gx causes the range of gx. So restricting the domain restricts the range, not all the time, but for some of the time, in this case it will, causes the range of gx to be a subset of the domain of fx. And once this happens, therefore f of gx exists. Alternatively, you can sub in these values, get the equation in terms of x, and then see what the values of x for this equation will occur, but that means you have to sub in f and g, and if you don't know what these are, or it's sometimes a bit easier to use this process. So a final example is if fx is equal to log x and gx is equal to 1 over x minus 4. So we want the fog to exist. So for this to occur, well, we find out what this equation is. So log 1 over x minus 4. But so for this, well, we know that g of x, the range, can be any real number apart from 0. And because the reason why it can't equal 0 is because when x is equal to 4, we have 1 minus 0, which is undefined. So this is the range. But the domain of this one, so we're looking at the domain of here, is x is greater, or not equal, so just x is greater than 0. So now we want, instead of x being there, we want gx. So we want the range of gx to be greater than or equal to 0. So this means 1 on x minus 4 has to be greater or equal to 0. And this can occur if we restrict the domain such that x minus 4 has to be greater than 0. Therefore, x has to be greater than 4. So if we let this happen, x has to be greater than 4, then this function will exist.